Starting off with, of course, we install the tidyverse. It expands the vocabulary of R. You can look at my other videos if you don't understand what that is, but the tidyverse is very important if you're working in R. Another package that I've installed here is Forcats. Forcats gives you some expanded vocabulary to work with categorical variables. It also gives us this lovely data set here, GSSCat, right? So if you've installed Forcats, you've got this data and you can practice the lesson that I'm doing right now at home on your computer. So let's have a look at that data. This data's got a whole lot of variables, one of which is marital status. Okay, and we're going to look at the marital status. And you can see, if you look at the bottom on the right over here, I've just drawn a plot where I've said never married, divorced, and married. And we can see that they seem to have different proportions. Now, when we do a chi-square test, this is what we're asking. We're asking, is there a difference in the proportion of people who are never married, divorced, or married? And there seems to be, of course. Our null hypothesis is that there's no difference, that they're all the same. We ask the question, does the data support that? A big thank you to Nested Knowledge for sponsoring this channel. Nested Knowledge is an online platform that facilitates systematic literature review and meta-analysis. Check them out, they're absolutely amazing. I'll put a link in the description below. Let's quickly look at that. Now, I'm not going to go through this code here. I've put it on the screen so that you can copy it if you want to, if you're trying to replicate this analysis at home. But this is just me cleaning the data up, creating basically a small data set with just one variable, and I've filtered out just marital status, never married and divorced. And I've dropped some of the unnecessary factors. And if I run that and look at my data, you'll see it's just a nice little neat one variable data frame. Okay, now this is where things get exciting. This is where we learn the chi-square test. You want to apply the chi-square test to a table. So I've created a new object called my table, and I've assigned to that my data. And we've basically used the table function, with my data as the argument. And if we run that, if we run that and view it, voila, we've got a little table with the data right there. Right, then we can simply apply the chi-squared function to my table, and voila, we get our answer, and we've got a p-value of very, very small. So we're saying it's extremely unlikely that if we did have equal proportions of these three, never married, divorced, and married, it's extremely unlikely that we would see a difference of the size that we are seeing. So we can reject the idea that they are all equal and accept the fact that what we are seeing is statistically significant. Now, I just want to show you how we can do all of that in one step using pipe operators. We've got my data, which is the object. We pipe it straight into table and pipe that straight into the chi-square test. And voila, we get the same answer. Okay.